Hey, what's up, Math 1? Mr. Bainey here again to take a look at lesson 12.3 and the last lesson of Unit 5 that we're going to cover when we will not be doing Module 13. But this lesson covers everything you've learned so far in Module 11 and 12. It's putting it all together. So it's everything you've known so far about how to solve linear systems of equations and linear systems of inequalities, puts them into real life context situations, and having you solve them in all different kinds of ways. And here on page 560, your turn, we're going to write a system of equations to represent the situation, and we're going to solve it. If you are comfortable with Module 11 and also Lesson 12.1, okay, there's nothing really new here. So we're just going to create our system of equations, and then we can use any method we wanted to solve it. So we have a company that wants to buy, or that has to buy, computers and printers. Each computer costs $550. Each printer costs $390. If the company spends $8,160 and buys a total of 16 machines, how much of each did it buy? So the 16 machines and this total right here, machines refers to the computers and the printers. And the question, which is how many of each, in this case, how many of each computer and printer did it buy? It's important to know that because we want to choose our variables that we're using in our system to represent what we want to find out. So C is going to be the number or how many computers, and then P is going to be the number of printers. So we want to set up a system, and that means we need two equations. We have our two variables. We're going to use C and P here, and we want to set up our two equations. So we're going to have one equation that uses the value or the cost of all the machines, all the computers and printers, and then one equation that's going to represent how many machines, how many computers and printers. So we'll do that second one. If there's going to be 16 machines total, that means that the number of computers, C, and the number of printers, P, if I add those together, I know that that's going to equal 16. Okay, so let's say they buy 10 computers, then they have to buy 6 printers according to the information here, so that equals up to 16. That's the first equation. The second equation has to do with the cost of these. So if each computer costs $550, the total cost of all the computers is 550 times C. Because if they bought 2 computers, or let's say 10 computers, that means it's going to cost 5,500, which is multiplied by 10. So it's 550C for the cost of all the computers, which means 390P represents the cost of all the printers. And we know that the cost of all the computers and the printers together is going to be $8,160. And we can use any method we wanted to solve this. I'm going to use elimination. So that means I want to eliminate either the C or the P. And I am going to choose to eliminate the C in this case. So if I multiply everything in that first equation, I'm going to get 550C plus 550P equals 8,800. Then I'm going to copy the other one, the second equation. I don't need to do anything to it since they're going to be the same number for both of my C terms. And when I go through and eliminate, remember that my plan was to eliminate those two. They're both positive, which means I'm going to need to subtract them. So subtract the others. That, again, the C's subtract to give us 0, and 550p minus 390p, it looks like it's going to be about 160p, and then we'll get 640 here, and if I divide, we will get 4, and that means it's 4 printers. So if it's 4 printers that the company is buying, and I know that adding the number of computers and printers together is 16, then I know that it has to be 12 computers. And therefore, my solution here, 4 printers, 12 computers. And you can go back and you can double check, right? Is that a total of 16 machines? And is that a total of $8,160? But checking that second one would require you to multiply 4 times 390 to get the cost of all these printers, multiplying 12 times 550 to get the cost of all these computers, and then adding it together to see if it equals that 8,160. Okay, and that's it for writing a system of equations. Now we're going to look at writing a system of inequalities. We're going to write a system for the given situation, and we're going to graph it, then determine if the point 8, 4 is a solution to the system. A student has to buy graph paper and printer paper. Printer paper costs $2 a pack. Graphing paper costs $3 a pack. She wants to buy at least 6 packs of paper, but wants to spend at most $27. So we want to figure out, it looks like, how many packs of graph paper, how many packs of printer paper. Because a graph is already pre-made for us, it's kind of nice. It tells us the X is our packs of printer paper, okay? And then the Y represents the packs of graphing paper. It's how many packs. Keep that in mind. It's how many packs of paper. So if the student is going to buy 6 total packs, then we know, oh, I'm sorry, I forgot this word, 2 words right here. At least 6 packs of paper means that it's okay if the student buys exactly 6, but at least means 6 or more, right? At least 6, so the student could buy 7. So that means we want to have greater than or equal to 6. And then at most $27 for the cost means that it's okay if the student spends exactly $27, but doesn't want to spend more than that. The most they want to spend is 27. So we want to put less than or equal to. Okay, this has to do with the money, the cost, and the 6 has to do with the number of packs. So here's our 2 inequalities. We got X plus Y, right? That's how many packs of printer paper plus how many packs of graphing paper. We want that to be at least 6. That's our first inequality. Second inequality is looking at the cost. Cost of printer paper is $2 a pack, so we go 2x. Cost of packs of graphing paper, $3 a pack, means 3y. And we want that to be at most $27. So this is going to require us to, if you remember back from 12.2, that we graph the line, figure out dashed or solid, and then shade the correct region. So that means that I'm going to graph x plus y equals 6. I'm not going to go into too much detail on how I'm doing this, but the line is going to look like this. X and y intercept are both 6. There's my line. If I test the point 0, 0, plugging in 0 into my inequality, 0 plus 0, is that greater than 6? That's false, so I will be shading everything over here. Okay, and so everything that's here, remember, is a solution to that first part. That means buying at least 6 packs of paper. At least 6 packs means that the student could buy, like if I chose this point right here, this is the point for 6 packs of printer paper, 9 packs of graphing paper. So it's okay that the student buys that much if they want to buy at least 6 packs. Okay. The next one, again, I'm not going to go into great detail, but the the y-intercept, like it's 9, x-intercept 13.5. My line looks like that. And I'm going to shade towards 0, 0, because 0, 0 is a solution. 0, 0 is like spending $0, which the student would be okay with if they didn't want to spend more than 27. But that's not buying at least 6 packs. But it does satisfy the second equation. They don't want to spend any more than $27. So that means I'm going to shade everything below this line and here as well. Okay, so all of that. Now the overlapping part, right, the kind of the darker blue part, is my sweet spot. That's my actual solution. Everything in here is a scenario where the student can buy at least 6 packs but spend no more than $27. So the student could buy, let's just go through all of these different scenarios here. Student could buy 0 packs of printer paper and 7 packs of graphing paper, right? That would be less than $27. The student could buy 6 packs of printer paper and 4 packs of graphing paper. That's that second point. The student could buy 6 packs of printer paper, 1 pack of graphing paper, or could buy 10 packs of printer paper and 1 pack of graphing paper. Now, is the point 8, 4 a solution? That means, can the student buy 8 packs of printer paper and 4 packs of graphing paper? So that point, if I drew my line accurate enough, is about right here. And it's just outside, just barely outside, because 8 packs of printer paper, 4 packs of graphing paper means it's at least 12 packs. Okay, 12 packs, so if I plug it in, let's see, here, in my first inequality, right, 8 plus 4 is greater than or equal to 6. That's good. But 8 packs of printer paper means it's going to cost $16, right, $2 a pack. 4 packs of graphing paper, $3 a pack, that's $12. Is that less than or equal to 27? Right, and that's false. So 8, 4 is not a solution in this case. Go ahead and try this other your turn. Pause it, and you will see the solution in a few seconds. And here's the correct system of inequalities, also along with the correct graph with the shading. As you can see, solid lines, it's shading in the middle, very, very similar to the last problem. It's the same context, right? We're still talking about packs of paper in this case. So x plus y is greater than or equal to 7 is this line on the left here. Greater than means that we're going to be shading above the line because we want at least 7 packs of paper. 2x plus 3y is less than or equal to 30, so that's this line. We're shading below since 0, 0 is a solution in that case. And so the solution's in between, just like in the last problem. If we're going to look at the point 8, 4, is it okay that this student with these restrictions that wants to buy at least 7 packs, not spend more than $30, is it okay that they do the point 8, 4? Is that a solution? And that is the point right here. So on the graph, yes, it looks like the student is okay to buy it. Just to check on our inequalities, is 8 plus 4 greater than or equal to 7? Yes. And is $16 for the 8, right? 2 times 8, and then 3 times 4. Is that less than or equal to 30? And that's also a yes. So 8 comma 4 is a solution in this case. Okay, that's it for this lesson. And we're done with the unit, right? Done with module 12. So we'll review everything, go back and watch some more videos. I appreciate you watching. Hope it was helpful. Have a great day and see you next time.